answering my questions. Now, again to the task. The task was to fill a glass with a liquid and hold it in your hands. And as you said, well, just stick to the liquid. I will come back to that later. And now, the outline you did was, well, first of all, you brought the theory. Well, you show the glass without the finger, the conditions for the observation of the objects, the surface of the finger, and scattering. Then in the experiments, you brought the colored glass, the angles of observation, different types of the paper. And in conclusion, the thickness of the glass is negligible, and the optical density, and as well the total internal reflection of the fingerprints. Now to the strengths and weaknesses of your theory. Well, you mentioned the parameters glass and its thickness and optical density, and the different materials and the angle of observation. You mentioned the blind zone, that was very interesting. And you did the energy approach. But quite weak was probably you brought some complicated figure, and it sometimes wasn't quite clear what was really important for you and what wasn't. And, well, I didn't quite get why paper was that relevant, because you said our finger has a coating, and paper does not have a coating, or, well, for heavy coating you would have to make it wet or something, but we can come back to that later in the discussion. Then, total internal reflection wasn't quite clear for me at the beginning. You have to explain again, well, especially this thing with the energy. And there were parameters missing, as I said before, in the task again. It says use a liquid, and you just use water and not any other liquids. And you didn't use any other glass forms, you always used the same type, and it would have been interesting to see what would happen if you have a curved glass, for example. And here I would like to, well, come to the experiments again as well. Again, total internal reflection, that was good that you showed it with an experiment. The blind zone, you showed for different materials, and you showed it, well, you explained it to me again when I asked you before. You took a look at the angle of the observation in experiments, and weak was probably the experiments for scattering. And as I said before, those different types of paper. And the comparison between the theory and the experiment was a little bit missing for me. So you could have mentioned again or said again, okay, you see now our theory, and we proved it with our experiment in this or this way. And now I'd like to come to discussion. If that's okay, I would like to start with the form or the shape of the glass. I was wondering, what would happen if we have, I mean, it's different if you have a water glass, as the one you gave us, and for example, a wine glass. What would change, or which, yeah, what do you think would be the appearance of the image then?
So, you know, in general, nothing changed, because we will have this effect. But if we have some other form of the glass, something like sphere, we only change angle of observation. So at some angle, maybe if we take some sphere, give me the bottle. Yes. So if we put our finger here, so we can, and look from this bottle, we can see not only our fingerprints but all our fingers. So,
yes.
But in general, physically will be the same.
Okay, great. Yeah, I agree with you. And now, again, a parameter you could have altered, and at the glass would be if a glass has a rough surface. All those glasses here, they have a smooth surface, but what would happen, do you think, if we had an edged surface, for example?
So, in some of our experiments, we have used a rough surface, and we can see the clear image of our fingerprints too. So, we can say that nothing changed if we use
Are you sure about that?
So, you know, it depends on the situation of the surface. If we have roughness at the border between glass and air, so not between glass and water, we can see our fingerprints bright. But if we have this surface between water and air, so in the internal surface, we observe the scattering. That's why we can see bright image of our fingerprints.
But don't you think that if we have a very rough surface, for example, that we don't see the fingerprint anymore? If we have a really curved surface of the glass? I mean, if we, for example, would make the roughness of the glass, if we would make the roughness of the glass greater than the reals of the
So,
finger.
you know, if we can apply our finger to this glass, we can see. But if we have so big roughness, the place of replacement for applying of the finger will be very small. So with our eyes we can say that, oh, we can see the fingerprints, but we can't see this part of finger.
Okay, and well, but if you agree that if we don't have contact in the roughness of the, well, you said as well, if we need this this optical, this fluid, this optical contact.
Yes.
But if the surface of the glass is not
Yes,
rough,
I agree with you. Absolutely agree with you. If we have, if our finger don't apply to the glass, we can't see. But we have some roughness, and at some roughness, our finger can apply. So we can see only parts of.
So we agree if the roughness is that small that the finger can cope with the glass, so we have optical contact, then it works with total internal reflection, and we can see the fingerprints.
So we can see fingerprint, but we can see image of finger, but in the small place, only in the place of contact.
Okay, so we see the fingerprint, but just in very small parts, so we can't see the whole image.
Yes.
Okay, I agree with you. I agree with you. Now, as I mentioned, you didn't use any different liquids, you just used water. What do you think could change the image or the appearance of the fingerprints if you use another liquid?
So at first I should say that it's quite difficult to change optical density of the liquid because the optical density of the water is about 1.3, the optical density of some oil is 1.5, and optical density of the glass is something from 1.3 to 1.8. So, but if we increase,
what is the optical, the refractive index of air?
yes,
that's 1, isn't it?
So
you say if we have the water, which you said is very similar to the glass, so we can neglect that. If we have the water and the air, we have total internal refraction. But I mean, water and air, the difference is very small. So can't we, if we alter the liquid again, wouldn't that have an impact?
So difference between optical density of water and air not very small. So
I mean, it's about 0.3 you said.
No, I said the optical density.
I mean the difference of the two.
So yes, of course, we're interested in the difference between optical density of air and optical density of air. So
water. Yes.
So if we increase optical density of liquid, we increase loss of energy. So it means that our zone in which we can see object behind the glass will be decreasing. And will be the same if we increase optical density of glass.
Okay, so I would like to move forward to the next point, if that's okay with you. Okay. Now I was wondering, you always showed objects well behind the glass, like when you put it behind. But what happens if you put something under the glass?
Okay, it's a very interesting question because, as you know, you can see in my presentation, on the walls of the glass we can see reflection of the bottom. So if we take some, can you use it? So you can see that if we take our glass and something on the bottom,
we can see the color. Yes.
Yes, we can see reflection of the bottom on the walls. So
okay, so do you agree with me if we say that, well, for example, if a light wave is moving into the medium, it's getting reflected on the ground of the glass, so we get the color, and then it's getting reflected at the walls again, so we can see it. Okay, good. We agree on that. Okay, great. Now to the next point. I would like to go into that as well about the different materials and the contact. As I said before, the grease. We already said we need this optical contact, and I was wondering, how did you make this with the paper? How did you try to?
I can show it to you.
That was really nice.
If you take some paper without water and apply it to the glass, so you can see that we can see the paper.
We can see it, yes.
Yes, but if you put this paper into the glass with water, so
yes, it's wet.
Yes, and
then we can see it because we have the optical contact.
Yes, that's why.
Okay, great. So we agree as well. If we would have completely dry fingers, we wouldn't see the image of the finger.
Yes,
okay, great. And can we take a look at your slide number 19 again?
Yes.
Experience of fingerprints. Okay, but what did you want to show with this here? I mean, here it looks like we have total internal reflection of the finger.
This I want
was just wondering.
want to show that here we can we have a loss of energy because beam goes from the glass to the air. That's why we have this layer of air and we have this loss of energy.
Okay, but if we now take a look at the picture you showed us of your fingerprints,
Yeah.
well, which area of the finger, so this part here or this part here, is bright or dark?
So here we can see image of a finger. Here we can see image
Well,
of
what do you
finger.
mean by the image of the finger? I mean, we need those
So-
rays to see the whole fingerprint.
So image of a finger is image of our skin. So because you know if
Or could you go probably to the picture with the air behind, with the air bubbles behind?
no, we can see in the place in which finger didn't don't apply to the glass, we can see reflection of the bottom. So
Yes.
that's
Okay,
why I want to show
But
it.
we do agree that the parts we do not see of the finger, I mean, we can see the fingerprints if we don't know where the finger is not. I mean, we
Yeah.
need those areas in between.
Here we can see.
And in which color does those areas have? I mean, do we
So
have...
it depends on the color of the bottom. If we have red color of the bottom, here we can see red color.
But is it just the bottom or is it generally the whole glass? I'm not quite agreeing to the bottom. I mean, it's in the
So
whole
in
glass.
this place we can see reflection of the bottom as I show you in this experiment.
Okay, yes.
And here we can see reflection of the bottom. And the color of this place depends on the color of the bottom.
But I mean, we don't just have reflection from the bottom. Don't we always?
No.
I
In
mean,
this
if we
place
have total internal reflection, aren't the light beams moving from, well, basically everywhere into the glass?
Yes.
And they could also be reflected by the other side, for example.
Your time is missed.
Don't.
That's because of the 5 minute which you have to read into.
Oh, okay. So I just want to thank you very much for the interesting discussion and. She said time is over. Did you? I have 1.5 minutes more. But han ikke kjøpt for den med takfangeren? Okay, yes. So how have you been? Okay, well, I want to thank you very much for the discussion and
Yes, the 20 minutes for discussion.
well, no, it's 12 minutes for a discussion.
10 minutes.
15 minutes for a
10 minutes
discussion.
for discussion and 5 minutes for review the report of report.
But isn't that together? I mean, it says maximum time of the.
It's just 10 minutes for discussion and for all of
Dat stimmt doch gar nicht. Staat auch schon wieder.
What's the problem?
It's in the rules. It says that we have 15 minutes time for the whole discussion and telling how public.
Well, we have 50 minutes for discussion, but we charge maximum 5 minutes for short review.
And she just
And
counted.
now we were at 1.5 minutes. I agree. She has 1.5 minutes left for the discussion.
Okay, 1.5 minutes. Okay, just to come back to the glass for a second. Do you agree with me that the air everywhere around the glass, for example here, has the same color on the image as here in between? Here. Okay, good. So we agree on that. Then I would like to take a look at the blind zone again, or well, you don't have to show it, but is there a minimum or a maximum of the blind zone, and how do you?
So I can show you this plan. We have constructed these plans with help of vanilla creation. So at some place we can't see object because you can see this red zone because here is zone of total internal reflection.
Okay.
Also we have some maximum. For example, at 71 degrees. But with our eye,
Well, yeah, here,
Yes.
where we see the curve, yes.
yes. So, but with our eye, we can see this maximum because our eye isn't a perfect optical system, and we can say
Okay.
that in this place the bigger intensity.
Okay, now to sum up what we discussed, I'm glad we agreed on the shape of the glass, on the form, and also on the surface, whether we have a rough or smooth surface, and of course on the color of the color beneath the glass. I'm quite happy that we agree in most of the points and could, well, go deeper into the problem with, well, yeah, learning discussion. Thank you very much.
Good morning, my name is Łukasz Błaszczuk, and I would like to thank you for your great presentation and discussion. However, I have some questions, both to the presenter and the opponent. First of all, in your presentation, you mentioned a term, optical contact.
Yes.
Could you please specify how close have to be two
So-
objects in order for there to be a optical contact?
Okay. In the literature, we found that optical contact observed when the distance between two objects is about nanometers. So,
Nanometers, right?
Some-
How is it in comparison to the wavelength? I think this is relevant as well.
yes, it depends on the wavelength, but in the if we consider only optical diapason, its optical contact for the optical diapason is about nanometers. So we didn't calculate it, and
Can I say something to that?
Yes, how do you?
Well, I think the wavelength has to be, if the wavelength is greater than the distance between, well, between the finger and the glass, for example. If the wavelength is longer, we do have the contact. If the wavelength is smaller, we don't have the contact.
You don't have a.
I would
Okay,
say.
okay, I understand. Okay. I would like also to ask you about this slide. I don't understand one thing. Where do you have the total internal reflection? At which border? Between
at the border between water and air. It's a horizontal
Between-
water.
water and air.
Yes.
Water is denser medium than air.
Yes.
Could you tell, do you agree or disagree?
I do agree that, well, water has the greater refractive index as well.
Yes.
So we would have total internal reflection could take place, for example, if we have a light beam moving from down here onto the glass. Well, but we do have total internal reflection here, where you have the border between the air and the glass, because the glass and the air are quite the same. So we would have total
Okay.
internal.
Thank you. I would like to ask you about your experiments. When you perform experiments, did you actually look from above, as it is set in the task, or you act from the side?
So we will look from the side.
From the side,
Yes.
not from above. Okay. And I would like to ask you if you are familiar with the following phenomena: frustrated total internal reflection. Are you familiar with that? Do you know?
Can you?
Are you familiar with a following phenomenon, following term? Frustrated total internal reflection. Are you familiar with this?
I don't think that in this case we have this restricted total internal reflection.
Okay. And one last question. In your experiments, when you actually could see an image of your finger, did you compare this experiment with actual image of the finger in order to deduce if the place where finger touches the glass is really bright or dark? Did you check that experiment?
So it depends on the light which comes from the medium, because in some cases the fingerprints can be brighter than glass, and in another case fingerprints can be walls can be brighter than fingerprints. So it depends on the light.
Thank you for answering my presentation.